Still pretty easy here. So we've got a car, it's traveling at 30 kilometers an hour in a straight line, and we want to know displacement from the starting point after 10 seconds, 10 minutes, 2 hours, and 45 minutes. So we'll think of first is just what the equations are. So in this case, it's traveling at 30 kilometers an hour. We've got constant velocity. And so the equation we just saw was displacement at a time t is just equal to the initial displacement plus velocity times time. And in this case, velocity is going to be a constant, so it's not changing. So it's just we're going to say v naught, say. So let's say v naught times t. Okay, so in our case, the car travel, what's the displacement from the starting point? So we're talking about a starting point, so therefore that initial displacement is just equal to 0. A bit of a trivial problem. V naught is just the velocity, which is equal to 30 kilometers per hour. And so we've been asked to find the displacement from the starting point after 10 seconds. We could do this in a couple of ways. And we're going to want kind of a sensible answer here. So after 10 seconds, it's only going 30 kilometers an hour. So it's just a bit less than the speed you would drive usually on the streets, 40 kilometers an hour, 50 kilometers an hour. And so it's only going to go a matter of meters. So we could either change this into hours. So this 10 seconds, we could write that as a fraction of an hour or a decimal of an hour. But I think in this case, it's going to be better if we just change this to meters per second, and then we'll just times it by 10 seconds. So let's just do that. So that's equal to, so 30 kilometers an hour, that's equal to 30 times, so just figure out what this is. Well, let's just change the kilometers to meters first, and we'll just do it without the fractions. You can use the fraction way if you want to, but we'll just do it the easy way. So that's 30,000 meters per hour. And if we want seconds, well, it's going to go 30,000 meters in an hour. And so in a second, it's going to go much less than that. We're going to have to divide that by 3,600 because there's 3,600 seconds in an hour. And so that's going to be, so 30,000 divided by 3,600, which equals 8.33 meters per second. Let's just do 4 significant figures if we're going to use it again, meters per second. Now I usually remember, I don't know why, but I remember like 100 kilometers an hour is roughly 30 meters per second. And so roughly that is. And so that's reasonable. So this would be, if it's 100 kilometers an hour, it's 30 meters per second. It's reasonable 1/3 of that. We're in the right ballpark anyway, 8.33 meters per second. So therefore, in this case, the displacement at 10 seconds is going to be equal to 8.33 meters per second times time is 10 seconds. I didn't write that out in full, which is just going to be 83.3 meters. And this was part A. So car will travel 83.3 meters in 10 seconds. So it's that speed is a little bit less than someone running 100 meters. A sprinter could run faster. Okay, B, which is sensible, it's pretty slow, 30 kilometers an hour. So the next one's asking in 10 minutes. We've already figured this out in meters per second. Let's change this to seconds. So we have got the time that we're looking for is equal to 10 minutes, 60 seconds in a minute, which equals 10 times 60 seconds, which equals 600 seconds. Again, we've got S naught is 0, so we don't have to worry about that. So S, 10 minutes, so the the displacement at 10 minutes, or the distance travelled at 10 minutes, is the same thing in this case, is equal to, so S naught was 0, well, let's just write it out, so S naught plus V naught T is the equation we use to find displacement. So it's just the initial displacement plus the velocity, as long as it's constant velocity, the velocity times time. And so that is going to be equal to 0 plus, the velocity is 8.333 times 600. Yep, 10 minutes is 600 seconds. 8.333 times 600 is equal to 5,000 meters, which is equal to 5 kilometers. So the car will travel. So the car's 5 kilometers in 10 minutes. Now I could do a check on that. So we also know, check, 10 minutes is equal to 10, so there's 60 minutes in an hour, so it's 10 over 60 hours, which equals 1/6 of an hour. And so 1/6 times, so it's 1/6 of an hour, and it's going at 30 kilometers every hour. And so that is going to be equal 1 divided by 6 times 30, obviously, is 5 kilometers. So we get the same answer. Okay, so could have done it either way. Could have changed that 10 minutes to hours first, or we can use the fact that we've already done this meters per second, so we can calculate 10 minutes in seconds and use this 8.333 meters per second. Or we can use this 1/6 of an hour, and it's traveling at 30 kilometers per hour. Okay, last one. Do this in black. So the time this time it's traveling is 2 hours and 45 minutes. And so we just need to change that to a decimal first, so it's just hours. So that's equal to 2 hours plus 45 over 60. So 45 minutes out of 60 would be 1 hour. Hours, which is going to be 245 over 60 is 0.75. Okay, so we're just changing that into hours first. And now we've got hours, so we're going to use kilometers per hour. So S, the displacement at 2.75 hours, is going to be equal to S naught plus V naught times T, which is going to be equal to, so our initial displacement, we're defining displacement from the starting point. Did I ask for displacement? Did I ask for distance? Displacement. They're the same thing in this case anyway, but just in terms of what I'm writing. And so therefore we're going to get V naught, so it was 30 kilometers per hour. Just double check that. Times the times 2.75, which is equal to 30 times 5. It's 82.5 kilometers in 2.75 hours. So the car is going to travel. Too many force questions, kilonewtons, kilometers. Car will travel 82.5 kilometers in 2 hours 45 minutes. All very easy, but just running you through it in case you're just not sure how to do those ones with the different units and so on. So you're always making sure your units are consistent. If you're using kilometers per hour, the time you use must be hours. If you're using meters per second, the time you use must be seconds. And if they give you something mixed, like 2 hours, 45 minutes, you have to turn it into, a decimal. And so you have to convert that 45 minutes to a fraction of an hour. So it's 45 minutes out of 60 minutes for a whole hour. And so we're getting 2.75 hours. Okay, next one.